Okay, example 10.2 from Giancoli is a 60 kilogram person with 2 feet covering an area of 500 centimeters squared. Determine the pressure exerted by 2 feet on the ground, and then we're going to figure out if they have 1 foot. Now we assume they're at rest, and we're going to be just calculating what their pressure is. Well, our pressure is our force per unit area. So here we've got a 60 kilogram person with a surface area here of 500 centimeters squared. And we need to convert that into meters because we want a force per unit area. So we want to calculate per meter squared. So 500 centimeters squared, remember how we'd calculate it, multiplied by 1 meter is 100 centimeters here. And we square that. That gives me, let's do this calculation right now, 500 centimeters over 100 squared gives me 0.050 meters squared. Now, what is the force? Well, the force is going to be the weight. The weight is equal to the mass times local gravity, and we'll just use 9.81 for this one. So we're going to find this is equal to mass times the gravity over the area. And let's put our numbers in. The weight is going to be 60 kilogram person. 60 kilograms. Oh, we've only got one sig fig there. Times 9.8 meters per second squared. Divided by 0.050 meters squared. And let's see, what is our pressure is going to be now. Force is newtons per meter squared. That's exactly what we expect of our pressure. Is going to be a force per unit area. So let's multiply 60 times 9.8 divided by 0.05 gives me 11,760. This is pascals. Newtons per meter squared. Of course, we've only got one sig fig, so let's just round that to 12,000 pascals. Now, part B is if the person's standing on 1 foot, we assume that we've got half the area. So the pressure so that's for part A. So for part B, we'd expect that the pressure would be double, so that will be 24,000 pascals. 1 foot versus 2 feet.